What's up, guys? Welcome to the stream. Okay, nice. As you can see by the thumbnail, today we are starting coding the renderer and loading models. So technically we started coding the renderer yesterday. Like we abstracted a bit. So a few things we just abstracted away. Yeah, that's kind of it. And I'm realizing it's pretty weird. Yeah, whatever. Fix it later. Yeah, I'm pressing shift and I'm going. Yeah, it's actually very weird. That looks weird, but whatever. Fix that later. I made a plan for how I want to start designing, and the first thing that we need is creating the shaders. So making the shaders different. So start off with the Vertex Shader. So the Vertex Shader is pretty much done. But obviously the hard part is the Fragment Shader. So the Fragment Shader, I will probably write the whole Fragment Shader out, even though we haven't got the input and everything set up, and model loading we didn't set up, and lightning, but I'm going to write it as it was set up. Yeah, because we will do that today. We will do everything of that today. So first we will define the maximum point lights, and then we'll define the maximum spotlights, like the maximum spot and point lights that are possible to render. And then we are going to define what the material is. Yeah, that's pretty abstract, I know, because we do it all now, and not like in small bits. Yeah, that's pretty weird, but whatever. That's like a diffuse and specular color and a shininess is what the material defines. And now we need a uniform sampler 2D for the diffuse. Texture, and uniform sampler 2D for the specular texture. And now a struct that defines a point light. Obviously a position. So it's K0, K1 and K2. Yeah, that's like actually, let me see. I think it is for calculating. For calculating how far the light is away and how shiny it is, like how strong. Yeah. Abdul Aziz, what's up, bro? Glad to see you in the stream, sup, dude. Yeah, cool. Nothing. Just starting on the renderer, like coding. How should I say it? Yeah, coding lighting and loading 3D models into a game that I'm working on. Yeah. That's pretty much it. Okay, so for the point light, we need ambient color, a diffuse color, and a specular color, like for every light. That's just how Pong shading works. Pong shading, because we're implementing Pong shading here. Okay, now a spotlight is pretty much the same yeah, like we could copy this, and now we need just one more vector which defines the direction of the light. Direction. And we need a point where it's a cut off point, like where the light cuts off, and yeah, outer cut off point, like where it cuts off outside, like it's like the spotlight is like a circle. Maybe you can find it on the internet. Spotlight. I think you know what it is, but maybe I can show it better. Yeah, bro, what the fuck? This is what I'm getting. Yeah, but as you can see, a spotlight is like this. Yeah, this. And obviously we need to know where it cuts off. Yeah, because it's like a circle. And okay, that's it for the spotlight. Now the next, yeah, that's now we directional light is also pretty easy. Just it doesn't have a collision a position, because yeah, it's not K0, K1, and K2, just a direction, because a directional light is just a light that's like the sun, and yeah, that doesn't really have a direction, and it's not getting brighter or darker. So yeah, that's all we need for that. Okay, now the variables that we put out on the Vertex Shader here, did I put them out? Yeah. We just take them in the Vertex Shader here. So yeah, and just make it in. Okay, text card we put in. So let's make it like that. Pretty easy. Okay, nice. Now we need uniform material, material. That just defines the material with what the pixel should be rendered. Material. And yeah, a couple of uniforms actually. Uniform int, a number of point lights, and number of spotlights. And now for kind of model stuff, yeah, and it's int, not a bool, because GL, oh, it supports it? Okay, I didn't know that. Yeah, no textures, because some models don't have textures and just vertices. And okay, now a uniform directional light for the directional light. So yeah, if we don't put anything in, there's not going to be a directional light rendered. Okay, so yeah, put in for the render pass, I guess. Spotlights is just an array of spotlights, and the size is max spotlights, which we defined here. And the same for the spotlight and for the point lights. And for that it's just max point lights. Pretty easy stuff. Sampler 2D. The texture, which with what we want to render, like the model, and the view position from where the model is viewed, so that yeah, so that we can calculate light properly for the diffuse light. I think it's needed. Yeah, okay, now we want to create the functions with which we calculate actually the lightning. So calc point light. So for calculating point lights, we need the index of the light. So because we can render more than one point light, Yo, Mr. Max 2! What's up, bro? Glad to see you again. Yeah, nice, bro. Very cool to see you. See you here. Yeah, I'm just working on the game again, and yeah, programming the renderer, doing casual programming stuff, you know. Okay, let me just see. Oh, that's not what I wanted. But yeah, like that. Okay, nice. Yeah, we need the view direction and the diffuse texture, I guess, and the specular texture. And we're not defining them here, just declaring it. And now for the calculate light. So for the directional light, the normal we need, then we need the sorry, bro. Why are you sorry? Bro, you did nothing wrong. But yeah, I don't know, man. Did nothing wrong. No need to be sorry. Okay, now for the spotlight, we need an index for that because we can calculate multiple spotlights, so we can take multiple spotlights in. The view direction and the diffuse texture. 1 ago you're live. Yeah. Still really don't know for what you're sorry. Maybe because you weren't there in the live. I don't know. If yeah, it's no problem, bro. Yeah. Okay. Now I think we should define the live stream. Yeah. So I think we weren't there in the last live stream, but yeah, that's definitely not a problem. Okay, like that. And like that. Yeah, okay, that errors they will go away if we return something. Yeah, I don't know, should I do it? Return vector 1. Yeah, they go away. Return vector 1. Okay. Now for the point light, we need the ambient light. The ambient is just the light that's like statically in the world. So like imagine the universe. Yeah, that's not good because in the universe it's pretty dark. But imagine a room that's like pretty much completely dark. Yeah, like some light source is always there and it's not always pitch black. Like it's a bit like you can see something, and that's the ambient light. It's always there. Like that it's not like pitch black. Yeah, that's what the ambient light is. Mr. Maxi, date me, uhu. Bro, I love you. Let's date. What language are you using? So programming language like this, and at the moment is GLSL. That's I think graphics library shading language, like the shading language for OpenGL. But for programming, it's C++, because yeah, it's pretty damn efficient, and yeah, obviously it's used a lot by the game industry. So yeah. Diamond pickaxe. Wait. Yeah, that makes sense. Makes sense to me. He's got actually pretty good memes. Okay, so the ambient is just the ambient in the spotlight, because the spotlight stores actually its ambient in it, because like it's a struct, times the diffuse map that we put in. Okay, so next the light direction. We also need that. It's just the normalized vector of point lights at index, the position of that minus the fragment position. Like that's, can I code OpenGL without shaders? Technically, yeah. Because like there are default shaders on your GPU, but like you need to understand that shaders are just the code that you write, like that the GPU is doing something, and if you want to see something on your screen, you need to tell the GPU, like your graphics card, what it should do. And if you don't do that, obviously nothing will show up. But most modern GPUs have default shaders implemented, so if you don't write any shaders, the color of every pixel will just be white. Yeah, but that's not like a real game or anything like that. So yeah, you need shaders, like most definitely. I think there's OpenGL compatibility mode, which you could try, but I don't know if you can specify colors or anything higher level. If yeah, maybe try that, OpenGL compatibility mode. But yeah, like you probably can't do that, if I'm honest. Yeah. But yeah, that's just how it is. Okay, so the light direction is just calculated by taking the position of the light and subtracting the fragment position, which will give us obviously the vector of the the vector that's pointing to the to the fragment position. Like it will give us that vector. Like where's my cursor? Like here's the light. Can't draw light obviously. Here's the light, and the light direction is like this. And yeah, that is what we want to calculate. And like here's maybe the player, and that's the vertex that we are currently processing. So we'll take the offset of that vector and that vector, and this will give us that vector. So the position from the lights to like the vertex that we're processing, and then we'll just normalize it so that we get the direction and not the actual vector. Yeah. Okay. Now we need to calculate the value, how the geometry is lighted, like by which value. I call it diffuse value, because we need to calculate diffuse, specular, and ambient. Like ambient is pretty easy, but the other two are not that easy. Okay, like it's the max of the dot product between the normal and the light direction. Yeah, the dot product of the normal and the light direction. Like, say here's the normal, like the surface normal is this, and the light is here, and the light is pointing like that on the normal. If we take the dot product of those vectors, the dot product is just projecting this vector onto another, and then treating this other vector that we projected the other one onto as a number line, like here's 0, here's 1, here's 2, and if we project this vector onto another like that, we get a value. And like here's maybe 0.7, I guess. And yeah, that's the value of the dot product. Like in our case, the diffuse value. And yeah, as you can see, if then like if the light was like here, like further away from the normal, the value would be smaller. It's like here, and yeah, so that yeah, it's pretty easy, because if the value is smaller, the light also is smaller, so we can calculate light with the dot product pretty easy. Yeah, and then we'll just clamp it to 0 so that it can't get below 0. That's pretty easy, I guess. Okay, now the actual diffuse color, I guess, is the point lights at the given index dot diffuse. Can I see? Cute cat. Oh my god. Love you. Thanks. Hope he's coming. Yo, Mr. Maxi, just like in Germany you would say Ehrenmann. Maybe I could translate it on Google Translate. Like you write it like that, Ehrenmann. Gentleman, yeah. Like it doesn't really mean gentleman, because like it's treated a bit differently, but like something like that, definitely. Yeah. Like very cool guy and something like that. Okay, nice. Okay, and now where were we? Okay, calculating the diffuse value. And now we just take the diffuse of the light that's stored in the light and multiply it by the diffuse value times the diffuse texture. And the diffuse texture is just a texture that we can like a texture where the diffuse value should go like more, and where it's less, like where, yeah, how could I explain it? Like, for example, we have this wood here. It's like a wooden plank, like that. And obviously, where those lines are, the light is reflected here a bit differently, like here, because obviously here the light is reflected more, and in the like here, it's reflected less because it's more in the ground, and for that you can use a diffuse texture. And with that, it's just a black and white texture that defines where the diffuse is more and less. Yeah, it's where it's more and less. That's pretty much it. And when the texture is white, it should light very much that area, and when it's black, like there should not really be any light reflected. Okay. Yeah, that's it for the diffuse. And by the way, Mr. McC, I have one question, which is, do you code? Like, if yeah, that's pretty cool. Like, do you code or do you do anything like that? Like, designing games in an engine or something? Yeah, pretty much interested in that. Okay, yeah, the next thing that we're going to do is the specular lighting. Okay, firstly we need the reflect direction, which is just reflecting the light direction, the negative of the light direction by the normal. So like imagine here being the normal, and that's the light direction. That's the light direction. Reflecting that would be just that, because we take the negative of it. So that's the vector we get up. That we get. Okay, Mr. McC writing. Yeah, I don't know if what should. Yeah, just say yes or no. Like that could mean I don't know, or definitely. Like say yes or no. That would be pretty cool. Okay, next the specular value, which is just the power of the max of the dot. I think he just likes your accent. Yeah, bro. I think you do too. Yeah. I mean, Polish and German together is equal to not very good English. Yeah, you can see that. Yeah, no. Okay, I think that means yes, no. Like you code, but you don't code. But you're coding. Like you are not. Yeah, you are coding, but you're not coding. But you're coding. Like you're coding, but you don't. But you're coding. Like yeah. Okay. Yeah, that's pretty hard. Just focus on the dot product. We take the view direction and the reflection direction and clamp it to 0. Yeah, so let me see. The view direction is, I guess it's just, yeah, the view direction is from where the player is looking, and this, like if the player, so let's like the light, if the player is, let's say here, no, let's say here, and he's looking in that direction, we take the dot product of both of these, and yeah, and that's the value, because the specular light is calculated by how the player is looking at the geometry. Like if the player is not looking at the geometry, it's not reflecting. Like if you're looking directly in the sun, there's no, it's not a good no, that's a bad example, because the sun is just blue. Like if you're looking into metal, and the sun is reflecting onto that metal, if you're looking, like if you're just seeing it in your corner of the eye, it doesn't reflect. But if you look directly into the reflection of the light, like it pretty much hurts and reflects a lot, and there's a lot of light, and that's what specular light simulates. Yeah, so it depends on the view direction of the player, and yeah, we're clamping that to 0 and taking it to the power of the shininess, so the material.shininess times 64. 64 is just an arbitrary value. You could do 16 here or something too, because yeah, it's just like the value how strong the light actually is, and yeah, the shininess is obvious, because we, like, if metal is pretty shiny but coal or matte things are not. Yeah. Okay, yeah, that's it. No, that's not it. We need the specular color, which is just equal to yeah, the point lights at index suns. I think you mean suns, like I know what you mean. You mean that. You mean sons of the forest. I definitely can look into your mind. Definitely mean that. Yeah, it's obvious that you mean that, because it's like such a great game, and I know that you like it. Go play it. No, it's not even out, but play it. Just play it. Just get any idea and play it. Okay. The specular times like the specular value, which we just calculated, times the specular texture, which we can take in. Okay, and the distance, which is just the length, like the distance. Yeah, the distance from the light to the player. Yeah, so it's the point lights at index dot position minus the frag position. Now it's not to the player, it's to the geometry, and the attenuation, like how heavily it's going to be visible, is u point lights at index dot k0 plus u point lights at index at k1 times distance times u point light at index dot k2 times distance, like just going up with the distance. Okay, that's it. Now, instead of returning the vector of this garbage, we return a vector of ambient plus plus diffuse plus specular, and the attenuation okay, diffuse color and specular color and ambient color. Okay. Yeah, I think that makes sense. Like, we add them all together, which gives us a final light color, and multiplying it by the visibility of the light. Okay, for the directional light, I think it's pretty much the same. Let me just copy and paste it. Copy and paste it again. Because okay, why isn't it? Roses are red, violets are blue. Yeah, I'm very bad at making those rhymes. I don't know. What the fuck? What the fuck? Why diffuse specular and diffuse texture? What the fuck? Yeah, whatever. Where is it? Diffuse texture times diffuse texture. Yeah, the light direction is just normalizing the directional lights, the negative of the directional lights dot direction. And wait, did we do something? We didn't. Okay, the diffuse value is keeps this is the same. Yeah. Okay, that's just replace you. Oh, he stops says if. He stops says if. That's actually a mysterium. I really don't know what you mean, but yeah, whatever. Yeah. Yeah, you're the directional light. Undefined variable. Did we? Let's say like that. You dear light. Replace. Okay, reflect direction, yeah, that seems okay. Power makes dots. View the reflect the specular. Yeah. Yeah, and obviously we don't need this. Yeah, that's pretty much it. Now, just the spotlight, which is pretty hard. Yeah, okay. First, we need the light direction, which we can copy. New spotlights. Now we need the FOV. Like it's not F wood. He stops says F wood. Huh. Like I would, yeah, it's like I would really understand it and I would really appreciate it if I understood it. But I'm like, my mind is like too small for that kind of understanding, you know. I think that's a problem. Okay, normalizing the spot lights at index.direction. No. Dot direction. Okay, now the ambient color is just spotlights at index.ambient times the diffuse texture. And if I'm not happy with that FOV thing, but let's just call it that, is greater than outer cutoff point. Like if we are if the theta, it's called theta, theta, I think it's, yeah, if the theta is more than the outer cutoff point, we want to yeah, like calculate the lighting. So the diffuse value is the max of the dots of the given normal and the light direction and 0. So clamping the dot product of the normal and the light direction to 0. And yeah, that's pretty easy, pretty normal stuff. And like the diffuse color is equal to the spotlights at index.diffuse times diffuse value times diffuse texture. Okay, easy. Now yeah, we probably can copy it from here. Okay, the reflect direction, yeah, that stays the same, but obviously, yeah, okay, that also stays the same, but here it's use spotlights. I have to go watch the screen later. Okay, but that's obviously not a problem. Thank you that you've been here. Very much appreciating that. Thank you very much. Yeah. Yeah, come back later if you want, and yeah, no problem. Wish you a great day. Okay, yeah, that's pretty much it for the Phong calculations. Now we need the intensity of the light. Intensity is just equal to the theta minus spotlights at index.outer cutoff point divided by spotlights at index.cutoff point minus spotlights at index dot outer cutoff point. Easy. Yeah, not that easy for the compiler, I guess. I think it's just, yeah, it was that. Okay, but that shouldn't be, because here, I missed it. Easy stuff. That's the intensity. Now we need to clamp it between 0 and 1, because yeah, our OpenGL and GLSL is laid out that way, so we need to do that, and multiplying the diffuse and specular color with the intensity. Pretty easy stuff. Now we need to get the distance between the geometry and the light. Also very easy. Now we need attenuation, which is just the visibility of the light. Also pretty much the same as always. First, spotlights at index at k1 times distance plus spotlights at index.k2 times distance. Yeah, that's it. Okay, now and just return a vec4 of ambient plus diffuse plus specular times attenuation. Ambient color, specular and diffuse color, obviously color. Okay, now if we don't hit that if statement, we just return the ambient color, because nothing needs to be processed. Ambient color. Okay, nice. Now we need, now that we have all of the calculating methods, yo, Mr. Maxi is still there. Didn't expect that. Nice guy. Pretty nice. yeah, calculating the normal, which is just pretty easy, just normalizing the given normal that is on in the in the vertex layout. Now the view direction, we need to get that. Okay, let's see. Bro, what the actual fuck? Bro, I don't know. Whoa, that's not on stream stuff. Like, is there still W? Okay, I think, yeah, YouTube will, yeah, I think they don't care, still, yeah, okay, the view direction is just normalizing the view position, minus the geometry position. And we need the diffuse texture and the specular texture, and we check if no textures is set. So if you're rendering without textures, then the diffuse texture is just material.diffuse, and the specular texture is material.specular. Like that, and as the diffuse texture is equal to texturing diffuse 0, and obviously with the texture coordinates, and specular texture is texturing. Sorry, no problem, bro. Like, if you don't do it again, there obviously no problem. Yeah. That's definitely not a problem. Okay. Now the result color, I guess, is a better name. And result color is just equal to clear light. Just using the function of view direction, diffuse texture, and specular texture. And now, for every point light, as listed u number of point lights, plus result color plus equal calculate point light with I is the index, and the normal that we get that we calculated, and the view direction, and the diffuse texture, and the specular texture. Yeah, and now the same thing with number of spotlights, like that. And we do calculate spotlight. Yeah, that's it. Now O color is just equal to result color. Okay, that's it for the shader. That was pretty long and a lot of stuff. Okay, 50 minutes work on the shader. Yeah, that's a lot. Like, a lot for a fucking shader. Okay, now we can start on refining the model class. I mean the mesh class. That's not a lot of work. We just need that was just for testing. We replace with with one texture, we replace with like a lot of textures. STD shared pointer of textures, like a vector of STD shared pointer. mesh textures. Okay, now we can name it textures. Yeah, and roses are red, violets are blue. We are talking about Bruno. No, yeah, okay. Yeah, if you want, do it. Like nobody said like that you don't, that you can't do it. Like do it if you want, bro. We live in a free country. Do what you want. Talk about Bruno all day long. Yeah. If it fills your needs, do it. Do it. Yeah, that's pretty much all. Everything needs to be rewritten. Yeah, but I think it's easy stuff. Okay, now for the constructor. Okay, we need few more things for the constructor. Yeah, we need in the class we need where is it? We need including assemp/scene that we get AI color 4D. I think we don't need that public. Specular diffuse, and just in the AI color 4D get specular const return specular. Mom, stop. I'm sorry, Mom. Ah! Bro. The real question is, where the hell do you get those memes from? Yeah, that's like actually the real question. Okay. Okay, now obviously we need no textures, because it's also in the shader. So obviously a mesh can also be initialized without textures. So we need a constructor where we don't have to define textures. Yeah, that's the texture constructor, and now there's the no texture constructor. AI color 4D diffuse, AI color 4D specular. Yeah, that's no texture constructor, and that's a texture constructor. That's how it goes. Okay, implement that. Okay, no textures. Oh my god. And that's sick. Bro. But let's talk about okay. Yeah, okay, no textures is false, obviously, and need to stretch my fucking back. Yeah. Okay, here initializing the vertices as the vertices, the indices as the indices, and the diffuse diffuse as diffuse. No, not this time. Diffuse. And specular is specular Tuesday. Whoa, that's a lot of time, like 6 hours difference. Don't you have school? No? Specular, diffuse, and no textures is supposed to put it through. And calling it. Oh, we're done. Yeah. The rest pretty much stays the same except for the render method. Can probably just delete it all. Okay, we check if no textures is activated. If yes, the shader instance dot set vec4 u material dot diffuse. We can access the different values. We just set to diffuse, and the same for specular. Oh yeah. Okay, we need a we need a overload. What the fuck? Why did I did that? Why did I do that? Maybe it was with the studio. I think it was. Where's the shader? Here it is. We need to include. I think it's just and paste that here, and go include SMC and make an overload for the set vec4 const SUD string main const AI color 40. Bro, I school tomorrow. Ah, nice. Me too. Whoa. AI color for the value. Pretty easy. Where is it? Like for real, where is it? It's not there. Oh, it's here. Okay, just share uniform for F, not for FV, because yeah, you'll see it gets uniform location ID name.cstring and value.r value.g value.b and value.a. Okay, nice. Okay, let's see. 6%. That's bad. Load it. Plug it in your phone. Yeah, pretty bad battery. Okay, that works now. Nice. And yeah, just shader instance set yeah, okay, let's just make it a bool and because we don't have a way to upload the bool. set int. Yeah, how did I call it? Ooh, pretty a lot of programming here today. No textures is just one. Int s. Diffuse index is is equal to 0. Specular index is equal to 0. Yeah, okay, let's don't make it like this. I don't know if it works or not. Specular index is equal to 0. And for every texture that we have, we activate it in OpenGL. So just textures at I bind slot I. Okay, now we need the name, like texture name, and we switch. Okay, we need to make adjustments to the texture class as well. So first we need to, instead of taking in a file path, we take in a directory and a path, and we need to include assemp slash scene for that. Discord. Why not? What should I see there? AI texture type, and also flipped is equal to true. Yeah, just a little bit like more adjustments to it. Okay, the AI texture type, and let's make it public. No, let's don't. Dir and path, and just make getters inline std string get dir const return dir. Get path, return path, and make them private. Nice. Yeah. Okay, now for the texture constructor, we just initialize. Yeah, and that's the wrong constructor. We need it like that, the definition. And instead of that, we just do dir plus a slash plus the path and the C-string. And we need to initialize the directory with the given directory and the path. Or like m directory, obviously. M directory and m path with the path and m type. Yeah, it's public, so type with type. Also very easy stuff. And yeah, that's it for the texture adjustments. Now back in the mesh, we need to switch on. yeah, that's the question. Where do we need to switch on textures that I dot type? Okay, now case AI texture type diffuse. If it's a diffuse texture, name is equal to diffuse std to string, just diffuse index plus plus texture name. Yeah, pretty easy stuff. And the same for specular. Specular index. Put that in shader instance, set int name, texture name, and textures at I dot bind. Okay, nice, easy. Now we need to bind our VAO. Call render command draw index on our VAO and VAO unbind and do GL active texture GL texture 0 for unbinding all of the textures. Yeah, nice. Okay, that's it for the mesh adjustments. Now we need to create a new class, which is the model class, because we want to render models. That's the goal for today, and if it's not today, it will be tomorrow, but I hope that it is today. Yeah. Okay. Yeah, we want to include our defines, obviously, core/defines, and we want to include the mesh, because models consists of meshes, and we want to include the shader. Yeah, and now, yeah, what the fuck, mesh.h obviously. And now all of the vendor include gfw/gfw. No, we don't need that. I didn't. No. Bro, what the fuck? We need to include glm. We need to include the assemp importer. Because now we actually are working on importing fucking 3D models. So that's pretty nice. And we want to include the assemp/scene, and we want to include assemp/post-process, and we want to include a vector, so like a vector class. Model, public, private. Obviously we need a position, which is obviously public, because it's very needed, and a size. I mean, the position is pretty important for the model, and the size is also. Okay, now a model constructor, just taking in a vec3 position, which is equal to a glm vec3 0, and a size, const glm vec3 size, which is equal to a glm vec3 1, obviously, because by default we want to take 1, and no textures is equal to false by default. Okay, nice. Now maybe default, no, we don't need a default constructor, but because that is a default constructor in itself. Yeah, okay, now that could be virtual. Yeah, the method actually could be because I think it's Borgia. That was just my chair scratching on the I don't know what the English word is, but okay, let me see. Regal. English. I think it's cabinet. It is shelf, obviously. Bro, I'm so dumb. I'm so dumb. My head is just dumb. Yeah, whatever. Load model. We obviously need that. We need a file path from where the model is, like where the GLTF file is. Okay, void render for rendering. Take in a shader instance and clean up. I think that if we make it private and make Constructor obviously too. Okay, bool, no. Yeah, obviously we need to make. Okay, that obviously can be private. Protected is no textures. Then it's okay, I think it's if it's protected, we just make it like that. A vector of meshes. Then a string directory, directory. Then okay, let's call it file path. Then a vector of textures, loaded textures. A function called process node, which will take like asmp node and a asmp scene. That's one image. Okay, it's nice. Maybe I could animate it with a sprite. I don't think it's animation. Like a cool. Don't actually know what they're going to do with that, but cool. Okay, nice. Yeah, okay, I think the meshes are always SCD shared pointers. And the shader is also SCD shared pointer. And yeah, and that returns SCD shared pointer of mesh. Yeah, which is process mesh. It takes an AI mesh, and the AI scene, and SCD vector of textures, and that's going to be a function texture. Yeah, of SCD shared pointer texture. SCD shared pointer. Load textures. AI material mat and AI texture type. Pretty easy stuff. Now we need to implement that with a CPP file. No. What? What? Refresh. It works for me. Is the stream not working? I don't know. Maybe it is not working. That would be pretty not nice. Let's see. Yeah, it works for me on both devices. Don't know about that. Okay, just implementing all of the methods. Yeah. Nice. Okay, and the constructor will just initialize the things. Size to size. And no, I think it's just no textures. No textures. Is it? It is. Nice. Okay, and the destructor. Oh. AI mesh. In the destructor we'll just call it cleanup. Okay, for load model we need to create a async importer and a scene, a async scene is importer dot read file, the file path. Like the scene is just like the given scene where all of the objects from the model are in. Like if you have a Blender scene, you will give the file path to that Blender scene, and yeah. Okay, process triangulate, I think. Process. You okay, bro? What should I say to this bro? Okay, yeah, we are processing with triangulate and process flip UVs, because we need to flip the texture coordinates in order that the texture is not upside down, because OpenGL and they read things differently, you know, the other way around and that kind of stuff. Triangulate is just a method of reading like vertices, and we use this method because we use it in our indices layout as well. Yeah. Okay, if the scene hasn't been created, or scene flags, the flags of the scene is AI scene incomplete. AI scene flags incomplete. So if this flag is in it, or the root node, like the main road, is not valid or not there, we'll not just CDC out, we'll just quickly include our pretty perfect logging library and call log error failed to import model at location, like let's say model at location, and then just the file path, easy, and return. Okay, the file. Okay, I think we actually need the directory, not the file path. That was a bit dumb. The directory. the directory is just equal to file path, so a substring of the file path. We start offset 0 and just find last of slash, like the last slash, obviously. So to the last slash is the directory. So from 0 to the last slash, like editor, if it's asset slash images slash player.gltf, it's like the last slash is here, so that's the directory, and that's pretty cool. Okay, now we after that we call process node, and the scene is just I mean the node is root node, and the scene is scene. Easy. Okay, now for the process node. Okay, now for processing the meshes, it's just for every meshes, num meshes, for every mesh, we'll process it. So AI mesh is equal to scene meshes at node meshes at I. So we'll just get yeah, the processes, yeah, so we are getting the scene meshes, like every mesh in the scene, like a player, and from that mesh we get like the arm or like another mesh. And okay, now because we are in the model, like in one model, we need we push back this mesh to our meshes, like the arm of the player, then the another arm, and like that. Okay, we push back the mesh. And now we push back process mesh, the mesh and the scene. Yeah. Bro, who is doing that? Like, who wakes up in the morning and says to myself, oh my god, I need to do that. I need to do a photo of me looking like that. Frogman. Okay, now for child nodes, also the same, like it's recursive and pretty nice, like for the child nodes it's recursively calling itself again, process mesh, now process node, we need to recursively call this function. Yeah, okay, that's pretty much it for process node. Now for process mesh. That's the big one. Okay, so we need a vector of vertices, like for the vertices, and a vector of U32 indices, and a vector of textures. Now, oh, that will be like so fucking long, but whatever. So for every vertex, no, AI mesh vertices, for every vertex will create vert and assign it like we want it, like the way it should be laid out. Dead man. Not Batman. Okay, AI mesh vertices at I dot x dot y and dot z, so that we get the position. The normal is like the same. Vert dot normal is not vertices, it's normals. Easy. And we check if we have texture coordinates. If AI mesh texture coords at 0, like if it's there, we'll assign texture coordinates to a GLM vec2 of AI mesh texture coords at 0 at I dot x and dot y. Yeah. Digga, I'm asking me where the fuck he's getting those memes. Like the darknet? Yeah, and as we just do the texture coords to 0. Put it to 0. Okay, and then vertices dot pushback the made vertex. Okay, now for indices. For I equals 0, I less than AI mesh num faces I plus plus AI face is equal to AI mesh faces at I, and for j is equal to 0, j less than face dot num indices I plus plus, because we want to get the indices of the face. Indices dot pushback face dot indices at j. Yeah, that's it for the indices. Not that hard stuff. In your mom is memes. Okay, didn't knew that. Material, yeah, now for the material. AI mesh at material index. So we check if the mesh has materials. AI material is equal to scene materials at mesh, so at AI mesh material index. If no textures, we check if we don't have textures activated. AI color 4D diffuse 1.0. AI get material color from the material. AI mat key color diffuse. We want to get the diffuse and assign it to our diffuse. And the same for the specular. Material. AI color specular, and it's specular here. And we return a new mesh with the vertices, indices, diffuse, and specular. So the non-texture variant of the mesh. CD shared. That's a lot of fucking code. Okay, now we have a vector of STD shared pointer of texture diffuse maps, diffuse textures is equal to load textures, the material and II texture type diffuse, and textures dot insert textures dot end diffuse textures dot begin and diffuse textures dot end, and the same for specular. Specular AI texture type specular specular textures specular textures.
What the dog do?
You made that? If yes, then 10 out of 10. Okay, need to keep going, because if not, I'm never going to see a fucking 3D hentai model on my screen. What? Oh, just joking. Vertices, indices, textures. Yes, did you make shared? Yes, did you make shared? Okay, finally done with this fucking method. Oh, now just the load textures method. STD vector texture textures. Yeah, and that needs to be like this. No. And for every texture with this type, we get the AI string and get texture type I and string. Okay, skip is equal to false, and for j is equal to 0, j is less than textures loaded. Loaded textures dot what the fuck? Loaded textures. Is a vector? Bro, what did I do? Loaded textures dot size j++, and we check if the string of we just check if the texture is in the loaded textures, and we do that by comparing the strings in loader textures, I mean. The textures. It's j.path, yes. Yes, definitely yes. Get path data and string dot c string is equal to 0. Yeah, so we check if yeah, we can do it as false. We check if they're the same and not the same, I mean, and if yes, we obviously push back unloaded textures at j. Yeah, I mean, if they're the same. And skip is equal to true, because we don't need to process anymore, because it doesn't make any sense to process. Yeah, for that it's very useful. And if we didn't skip, we create a texture, std shared pointer texture is equal to std make shared texture. Okay, how do I dir path bool dir path? Okay, dir is directory, path is string.c_string, type is the type, and flipped is false. Whew. Texture, yeah, we'll call that text. And textures dot pushback text and textures loader textures dot pushback text, and finally return textures. Boże święte. That's taking a lot of time, like a lot of time. Yeah, okay, the cleanup effort, it's nothing for now. Okay, but I think we can actually fucking try out a model class. Let me see. If I don't have any lights. Okay. Yeah, we need just a few things, which are yeah, a few things. First, light.h and light.cpp. Yeah, I'm going to copy that because I'm a copycat. Okay, I can't. Where is it? It's light and material. Okay, we need those. And compile them. Like, we don't need to include that. Yeah. Okay, light include core/defines, and we need a shader, float, don't need that, shader, shader, shader. And that needs to be a STD shared pointer. We obviously don't have that. I'm getting very tired of coding actually. But I want to get that done today. So I'm fucking going to do it. Keep on moving, guys. Yeah. Like that. No. Set float. Set float, set float. Set vec 3. Set vec 4. Set vec 4, set vec 4. Wait. Okay, we need to... Yeah, I named them wrong. Not like wrong, but I'm using other names in the CPP code then. Yeah, that's obviously not possible. So, we, yeah, let's call this UNO-text. And UN spotlights and UN point lights. Point lights, point lights. Yeah, okay, cool. Yeah, nice. Here it's spotlights. Spotlights. Yeah. Nice. Pretty nice. Now, it's just a question of time. I don't know what I'm saying. UNO-text. And where were we? I'm pretty... I'm losing focus because I coded like a long time. Like I'm coding for I don't know how long. Maybe it's not even that long. What was that? Set like 3. Set like 4. Set like 4. Set vec 3, set vec 4, set float. Okay, counter, yeah. Fuck. I'm regretting a lot. Okay, just change the code a bit up. Yeah, my fingers are very like, yeah, they're fast. That's what it is. That's what it is. Okay, set the float. Set a vec 3, set another vec 3, and set a float, set a float, set a float. Yeah. Are there any other? No. I think there are not. Maybe there are, and dumb. Probably there are. Yeah. Anyway, we need another thing which is a model folder. Models. Yeah, like that. They are internal models, like a cube or something like that, because it doesn't make sense to load in a cube if you can program it. You know what I mean? OpenGL/light. Ah, yeah, that's rendering/light. Rendering. Go, 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 go! Yeah, exactly. Float. Init. Meshes. Pushback SCD make shared mesh. Vertex. Generate vertices. Yeah, perfect. Oh, that's so nice. Okay, now the lamp. Render is just. Yeah, okay, I think where's the model? Let's make this virtual as well. Where's the lamp? It's here. Render. And SCD shared pointer. And set vec 3. Cube render. Oh, that's beautiful. Okay, now I'm not going to implement. Okay, I'm not going to implement a this with the render. I'm going to do that next time, but still I'm going to implement it with the application. So yeah, I'm pretty dumb. Okay, like we need a directional light, and for that we need to include rendering /light, and let's call it MDR light. MDR light. Then we need point light positions. Fuck. Okay, let's say for nice. Point light positions. Lamps. Let's include rendering /models /lamp. And a spotlight. Also pretty nice. Spotlight. Okay, that's not initialize it, because yeah. Okay, and lastly, yes, the SharePoint model. Fucking model. Nice, okay. Now a few things need to happen in the init method. Okay, we can remove that pretty much entirely. Now, we need to say spotlight, spotlight is equal to spotlight yeah, I think we can do that. Wait. And that's just need to do that behind that. M player game instance dot game instance game player get camera dot get position, and there it's get it's inline back GLM back 3 get front const return and front m camera front get front. Nice. Okay, initialized that, and now before that memes for you. No nuts. Coco cry memes, new collection, new best collection. Very scary. Like, that's very scary. I mean, yeah, that's just how it goes. I mean, things are just scary things. Yeah, I think we can all agree on that. Lamps, point light positions. It's just point light positions, and that's lamps. Dot. In it. Okay. 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 Now, before we do anything, we'll just quickly copy pretty much all of that. No, we won't. Was Apoxes? Welcome to the stream. What's up? Is 10k. What's 10k? Yeah, okay, so firstly we have a shader instance here. We have bind the shader, set AVAC 3, no fucking heck, view pos Camera. Soll ich auf Discord schicken oder wo? Ja, also schick's mir einfach auf Discord. Like, ja, mach das. Wäre cool. Ja. Get camera dot get position. Oh, fuck, ey, nein, lass es, stop it. Okay, Bro, und wann machst du das dann? Ich würde mal so schätzen, ja, wenn ich halt Zeit habe, das wird ziemlich bald sein, weil ich wollte es eigentlich gestern machen, aber dann hatte ich mein Handy nicht und ich konnte dir nicht schreiben, dass du es mir schicken solltest. Vielleicht machst du sogar noch heute. Ich weiß nicht. And for all English people here in the stream, yeah, that's one of my bros from Germany, and yeah, he's obviously German, so I'm talking German with him. Yeah. Get view matrix, and projection is equal to what the what the flip? What the actual flip? Ja, bestes Wort überhaupt 2004. Yeah. Okay. Sorry for the weird stuff here. Sorry for the weird stuff. Yeah. Okay. Now, the moment of. Yeah, I don't know what I should say, because we render the fucking model, and then we do a lot of, yeah. Okay, now we upload shader, set mat 4 view to the view. Projection to the fucking projection. The last steps on seeing a fucking model in our engine. Directional light dot direction is equal to GLM vec3 GLM rotate. We want to rotate it around a identity matrix. Easy stuff with a radiance degree of like 0.5f. Ja, Bro, danke, Bro. Falls du noch Zeit hast, nicht nur, falls du noch Zeit hast, Bro, ich meine, du musst, bleib noch, weil gleich sehen wir einfach Models. Ja, danke. Ich finde das fand ich auch cool. Ja. Okay, direction and 1.0. Hope I did not something. Yeah, I did. Yeah, done. Back 4. Okay. Ey, wehe, du bist gegangen, ne? Ich schau jetzt bei Teilnehmer. Oh no. Oh! Ey. Ja, komm mal in 5 Minuten zu. Was grad? Ey, Bro. Kleiner Hurensohn. Okay. Render, just rendering the directional light. Yeah. And for U32, I is equal to 0, I is less than 4, I plus plus, rendering all the lamps, lamps dot render, no, dot lamps, no, lamps at I dot point light dot render at I and shader. Yeah. Okay. And then shader. I know it's a lot of stuff, but set int un point lights to 4 because we want to render 4 point lights, and if yeah, that's okay. We need a new quick new shader. Just lamp fragment.glsl. That's everything. And now where's the fucking application? Wie lange bleibst du on? Vielleicht nicht mehr lange. Bro, hier. Vielleicht nicht mehr lange, weil ja, meine Mutter kommt gleich nach Hause und alles. Deswegen ja. Okay, STD Shared Pointer Shader. Okay, jetzt muss ich echt schnell sein. Lamp Shader. In der init, wo ist die fucking init? Where's the init method? I mean, oh, I'm fucking not initializing the normal shader. Shader is equal to std make fucking shared. Make shared shader assets slash shader slash default vertex.glsl and assets slash shader slash default fragment.glsl. Lamp shader is equal to std make shared shader assets. The vertex shader key is the same, but it's another fragment shader, so it's assets slash shader slash how did we call it? lamp fragment.gsl, and yeah, okay, nice. Now now we want to bind the lamp shader because we want to render the lamps, and lamp shader set mat 4 view lamp shader set mat 4 view projection run speed coding at this point, rendering all of them. Lamps at I dot render bro lamps at I dot render with the lamp lamp shader. No, fuck. Please don't start. Please don't fucking start. I'm so dumb. I'm so fucking dumb. I'm so dumb. I'm a dumb idiot. Where is the fucking thank you? I love you. I love you all. I love my mother and my sister. I don't even have a sister. Yeah, was ja, Luca-Probleme. Ja, halt seine fucking Fresse, Junge. Fucking load! Ah, I'm so dumb. Hey, yo. Yeah, definitely, hey, yo. Model is equal to std make shared model. Yeah, I need to be speed coding. Like, what the hell am I doing? Position, size, no textures. Huh? Okay, so the position, yeah, it can stay like that, and then model load model asset slash models slash player slash scene. Let me see, scene dot gltf. Okay, yeah, start, and let's see what all the fucking errors are. Just start. The errors are in. Yeah, they're everywhere. Okay, what the fuck? Okay, maybe it's because of multiple, like singular, yeah, I can't even talk at this point. Model is including RPC, okay, yeah, it's okay. Model is including mesh, yeah. Mesh, it's constructors like that. And I think it is because of that, maybe? Or is it because of that? Diffuse in Specular is AI color for the vertices. What's vertices? Where is vertices? Yeah. Oh my god. SCD shared pointer. Obviously. Let's see. Yeah, that's my heartbeat. I'm not punching my table, that's my heartbeat. Yeah. Yeah, okay, there's a fucking DLL. Don't know why, but there is. Okay, let's see. Where's the shitty DLL? I don't even want to link a fucking DLL. Like, what the fuck? I don't care. I don't even want to link it. Okay. For some reason, we need to. Because it's async. Yeah. Okay, so in bin debug, we need to paste that in. Okay, and start. It was so fucking obvious. Okay, what's happening? Yeah, huge memory leak. Nothing's happening. Okay, let's maybe wait. Maybe the model is like... What the fuck? Look at that memory leak. Bro, I'm breaking my PC. Like, what the fuck? That was 1.5 gigabytes memory leak. Gigabytes of RAM memory leak. Yeah. Maybe. Yeah. That's very weird. That was very weird. Indeed. Okay, let's test if we can... Where is it? That's the init, am I right? Yeah, that's the init method. So we're not like loading the model every frame or something. What if we put a wrong file name? It works. Like it yeah. Okay. So the error lies somewhere else. Bro, stop freaking out. Yeah, bro. Yeah, okay, you're right. I know. I'm pretty dumb. Actually pretty dumb. But load model. Just importing the scene, read the file, AI process, triangulate, AI process, flip UVs. Directory as file path.substring 0, find last of. That makes sense. Processing the root, processing the node. Oh, the render method. I fucking forgot the render method. That's probably not the error, but it's like very dumb. Okay, need to make obviously a model matrix, translating it by the no, not transpose. What the fuck? Not transposing, just translating, and the translate is in GLM GTC matrix transform. Translate. We want to translate the model by the position, and we want to scale the model. The size and shader instance set mat4 new model to the model and shader, yeah, definitely shader instance set float u material dot shininess 0.5. You cool, bro? Yeah, I am just a bit nervous because yeah, I mean, Maybe it's because of the shared pointers. If it's that, then I'm probably gonna figure out. Shader instance. Okay, let's see the process node. Okay, we are going through every mesh, creating a mesh. That makes sense. It also makes sense. It also makes sense, I guess. Maybe it's because of the process mesh. Yeah. Looks fine. Looks fine, looks fine. Yeah. The live stream is 2 hours now. Cool. Like, not that cool for my life, but cool for YouTube, I guess. AI get material color of material. AI mad key color diffuse. And AI get material color material. AI in specular return. STD make shared mesh. Vertices, indices, diffuse, specular. And load textures, material, diffuse textures dot begin dot end, insert, makes sense. That makes pretty much all sense. Programmers be like, I want something that fucking doesn't make sense. Everything that makes sense is just not cool, like, yeah. Vertices, indices, textures. Get texture count of type. I++, AI string, met get texture type, I and string. Bool skip for j is equal to 0, j is less than loaded textures, j++ if string copy, loaded textures at j, get path dot data string. You use assemp or making loader from scratch? I'm using assemp actually. Yeah. And like I have a big error. Like yeah, that's the error actually. And you see, look at this fucking memory leak. Look at it. Look at it. I mean, I think I'm going to kill my PC if I'm letting it run further. Yeah, I have no idea why it is. I have no idea. Let's just return a mesh with vertices set to nothing, and set to nothing. That should work, but it doesn't. Yeah! Let's fix the fucking error. Okay, like, the first thing is a vector of vertex. So, yeah, ignore the Discord messages. Vector vertex. And a SCD vector of U32s. And a STD vector of STD shared pointer of texture. Yeah, okay. Let's make that. Yeah, there is a fucking default constructor, and I'm not using the fucking shit default constructor. Yeah, I know it's not you. It's Apox's. Yeah, let me see what he wrote, but not now. Let me remove that and see if it works. If yes, that would be pretty nice, because we know that there was somewhere there. Okay, I think it worked, actually. Because, I mean... Okay, like, what if we just did that? Probably the same error. Yeah, I mean, it's literally the same thing. Vector subscript out of range. Okay. If you want, do it. Let's see. Maybe just copy the... Yeah, okay. Yeah. Maybe just copy it. Can I just return STD shared pointer mesh? No, I can't. But why? Can I do this? STD shared pointer mesh red and STD make shared. No, red is equal to STD make shared mesh with that, and then just return it. Yeah, okay, that's his, okay, Discord's not working. That's his, yeah, 2-1. Okay, let's see. I know that it won't work, but I'm trying to make it work, but it doesn't. I mean, look at that. No, don't look at it. Fuck, 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 fuck. How? I did something. Yeah. So, I think, here. Like, that was a model loader I did. And it works. That model loader was coded very different to the model loader I'm programming now. So that's kind of garbage. Bro, even got flashlight. Never realized that. Very cool. Very cool. Yeah. Okay. Now, what is the name? Which name? Yeah. I'm so confused by everything. I'm not confused by everything, but I'm confused by a lot of things, I think. Yeah, I'm confused by myself as well. AI mesh, 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 AI mesh. No textures. Mesh. Texture. Yeah, I'm writing it that way that it's not with shared pointers, because I think they are weird. Load textures. Texture. Load textures. Mesh. Okay, now removing all of the weird STD shared pointer stuff. Okay, I can't remove it like that. I could, but I'm not going to. Yeah. Mr. Makes see how many groups? A lot. A lot. Yeah, okay, that can stay. But mesh. Dot render process mesh. Where is it? Not a SVD shared pointer. And here's a vertex, and here's a texture. And that's a vertex. And that's position. That's normal. That's text code. That's text code. Oh. Obviously that's no, there are no SCD shared pointers here as well. Yeah, they can stay. The STD shared pointer will not stay. Where is it? Where is it? In mesh.h. It's STD shared pointer. That's going. No! A! Oh my god. I was thinking that Visual Studio's crashing, but it didn't. Dot. Easy peasy lemon squeezy. Okay, look at the errors so that we are seeing where we missed something. You know how it goes. Like 12 errors, that's a lot. Yeah, a lot of textures, obviously. Yeah. That's a pretty big rewrite. Oh. It doesn't return that anymore. And that's a dot. And that should work, I think. Oh, shouldn't it? Yeah, it should. But maybe, yeah. Okay. And text should not be a city shape pointer. Let's compile again. Cube. Where's cube? What is cube? Push back a mesh. Just a normal mesh. Like C++ error like descriptions. Like what do we bro, oh my! Oh my! Like there's no color, but oh my fucking god, I'm sorry that I'm screaming, but yeah. I'm one of the best programmers. No, I'm not the best programmer, but I'm one of the best programmers here on the like like yeah, I mean it's not like entirely working, but it is like a bit working. And that's actually pretty cool. And yeah, okay, that's like not a big accomplishment. Yeah, I know that, but fuck yeah. Fuck yeah. Oh my fucking god. Oh my fucking god. Okay. Now. Yeah, now. We need, obviously we need the textures. Like maybe. No. What if I'm set it to, I'm going to set it to true. What happens? I think it should be white. Like if it's not white, it's probably because of the shader. What the fuck? Okay, it's not because of the shader. Yeah, whatever, I fix it on next stream. Because yeah, I'm very like I'm very tired of working, I guess. Yeah. Yeah, I think in the next stream we will be texturing the guy, the girl, it is. Yeah. Okay, Apex is calling. Jo. Was geht? Jo. Bro. Like, guys. By the way, it was on stream. Lief lieber einfach den Call. Es wird besser für dich.
Hallo, Bro.
Ja?
Streamst du noch?
Ja?
Ja, ja, egal, scheiß drauf. Aber Bro, guck mal, ich hab dir jetzt
Warte,
das
ich kann,
geschickt, die Sachen.
warte kurz. Ich kann kurz
Und
auf Be Right Back machen.
okay, mach das.
Okay, guys. Yeah, Apex was calling, and yeah, you know how it goes. But I think we accomplished a lot today. Next time, maybe we'll work on the renderer, like probably yes, and obviously get the models to load correctly, like especially the textures. Yeah, fuck yeah. Yeah, I don't know what I'm doing, but yeah, I think peace out, guys. Have a great day, and